Welcome to the project demonstration of buck converter by using PIC microcontroller. So here we are using PIC microcontroller to do the buck operation. The main application of this project is in order to regulate the output voltage which is getting from this regular power supply board to the required voltage. So here the input voltage from this regular power supply board is around 14.5 to 15.5 volts, which is a variable DC input voltage, and that is the input to this buck converter, and the system will measure the input voltage which is parallelly given to the buck converter, and output of the buck converter also will be measured continuously, which is a closed loop manner. So initially the system will start with a low voltage, then it will keep on increasing the voltage to the required voltage. So in our PIC microcontroller we programmed it to make the required voltage to 5 volt. So whenever the system reaches around 4.5 to 5 volts, then it stops increasing the pulse width to this MOSFET here. So here the system start increasing the pulse width modulation. Whenever the required voltage reaches, then it stops the lock that particular pulse width at the particular duration to require the voltage was reached. So that will be continuously displayed on the LCD screen. So here the main power supply is flow is we are providing 230 volts AC inputs to the transformer. So it will step down the 230 volts AC to 12 volts of AC, and to this regulated power supply board it has the 3 stages: rectification with the help of these 4 diodes, filtration with the help of this capacitor, regulation with the help of this 7805 regulator. So as we are using this regulator to get the 5 volts DC outputs to our microcontroller, and parallelly same 12 volts, nothing but around 14.5 to 15.5 volts, that is our VRMS voltage, is the input to this buck converter, and parallelly same voltage is input to the microcontroller from this voltage sensor. We are using the voltage sensor of 10:1 voltage ratio, means whenever the input voltage is 10 volts, then the output from this voltage sensor is 1 volt. In our microcontroller we programmed it in such a way that whenever the input voltage is 1 volt getting from this voltage sensor, it will be multiplied with the 10, as we are using the 10:1 voltage dividing ratio for the voltage measuring purpose. That is given as input to the A0. A1 pin of a microcontroller is buck converter outputs, and B2 to B7 the interface to the 16:2 LCD screen. So on this motherboard we can see the reset switch to reset the microcontroller, crystal oscillator to provide the 20 MHz of crystal oscillating frequency to this microcontroller to execution of the instructions. So let us see the demonstration directly between on the power supply. So welcome message displayed on the LCD screen. Right. Okay. I'll show you that. Just reset this. So welcome message will display, and then after input voltage is 17 point. Yeah, right. So 17.45 variable voltage, and output is 4.64 and 7 times sometimes based on the required voltage. Whenever it is more than 4.5 volts, and it should be less than 5 volt. So we are going to log that output voltage in between these two, 4.5 to 5 volts. That's a buck operation. So it's a continuous process, right? Thank you.